Hello and welcome to the next chapter of advanced course. It's called HVAC, Heat, Ventilation, Air Condition, Control Systems. First of all, I should say that you can go and study the HVAC course from the KNX Association, that it provides you very detailed information about the HVAC systems, especially for room. And of course we have this chapter in advanced course, so now we are going to cover it. The second important things before start I would like to say is we are going to focus on the solution for HVAC in rooms. Okay, so for mechanical rooms it's not covered in this chapter or in the HVAC course. So we focus on room automation, so we are going to study more about the devices and control of them in the room to provide the proper air condition for the people. Yes, so let's go. First of all, if you are seeking to provide the energy efficiency in rooms, as well as provide the enough comfort situation for the people, you should set the set point of the temperature according to the needs in a building. Okay, so for example, if we have the flats and during the winter we want to set the set point, we put the set point for bedroom and kitchen equal to 18 centigrade. For children room it should be a bit warmer. As a comfort selection, it's 21. Also the living room. And about the bathroom, it should be 22. But for example, the hallway, it's a bit lower. Okay, so when you reduce the set point during the winter, you can save more energy. Also, when you provide the upper set point for some rooms like living room or children room, you can provide the better comfort for the people. So this chapter is a start to provide you some key information of setting the set point in the rooms. As the book said, KNX offers corresponding components for the various control options, individual room control. We will cover it in more detail. Heating and cooling circuit control and boiler control. So for the mechanical room controls, I think to this date only the company named ABB and Siemens provide us the nice solution to control over those devices, but most of the products from the other companies only focus in control of the HVAC in rooms. Then a next part, the book set the requirements to the climate control systems in smart building. So we should take care about temperature control. Okay, it can be the temperature control in rooms, or make it connection and relative to the outside temperature to provide the compensation mode, or we provide time control to set the set point. Okay, also the book said some very key standards are coming to help us to save energy. It provides us some rules to follow it up and reach like 30% or more saving of the energy. Meanwhile, you can focus always into EN 15232 to provide you more information from European standard. Also, we should take care about the energy certificate that the BMS can help us to upgrade the energy level usage of the building. A result of the before sales regulation in the end of the energy certificate of a building, of which the German version is shown underneath, the way such a certificate is established can however be highly complex, hence not explained below. Just you should know that according to the energy usage of each building, there are some special companies that provide examine the building and then provide a detail like the picture you can see here. Okay, so for now in the developed country your building should be in the green zone. Okay, but of course in other countries they try to reach the green. The planning of the heating system is generally carried out by the specialist heating engineer under certain criteria. So the mechanical engineer is responsible to design the right mechanical part of the project. Okay, these criteria is type of heating selected by the customer according to the type of primary energy. So the customer wants fan coil unit or radiator or underfloor heating or whatsoever. The heating curve depending on the type of the heating and location, so this is the calculation part. Capacity of the heating elements, building type in watt per square meter, room temperature costs, heating control that it needs some costs and also it helps us to save energy. An important selection criterion is the price of the primary energy which is available at the installation site. It is less the current price that consider and more the price development of the last few years and the prognosis for the next few years. The investment cost and operational cost for the system must however also be noted when selecting the type of primary energy. Example, storage room, oil tank, oil pump, and corresponding control technology for fuel oils. So here the diagram below shows a comparison between the different energy types. You can see the comparison between different energy types, heating, oil and fuel, electricity and gas. You can see during the years the electricity gets more popular. Okay, so from here in book you can read more comparison between the statistics and understand much more about the different type of the energy that we used in building to make it warm or cool. Okay, the structure of the heating system consists of the following component: heat generation, something we need to generate the heat, boiler. Heat transfer, so the heat transfer in it's happening here, so you can see, and also the heat consumption. So this heat is transferred to the room and it's consumed in that place. About this picture, you can see it's the example of a single boiler system with domestic hot water storage, DHW water, this one. A direct heating circuit here and two variable temperature heating circuits. Okay, if you need more information about these pictures and understand it, you can go to the Cinco 700 devices from Siemens and study more about it. It is coming from the Siemens book according to my experience. And only in a book it is mentioned that some heating system consists of boiler to generate the heat, domestic hot water, DHW water, tank, heating circuit, and variable heating circuit. Okay, so if you want to control the mechanical room components, you should take care of this part and understand this. You can see in this picture we have the boiler, we have the temperature inside of the boiler to read the temperature. Also, in return to the boiler, we have the three-way valve to save energy, and if the supply and the output hot water is not used in the building, in return we can use this three-way valve, for example, and returning to the system to make the boiler switch less. Okay, great. Also, you can see the pump in a heat circuit, in variable heat circuit, that and that we can control it, and the temperature sensor after the pump. Also, you can see the motor valve or three-way valve here, also in variable heat circuit, to use the return hot water. And then you can see the DHW tank with temperature sensor inside of it, and the pump to make the circulation. Okay, great. Also, with the output from the boiler and return to the boiler, we have the temperature sensor to make the best decision for this motor. And at the end, we have the outside temperature to make the weather compensation possibilities to save more energy. So this is the heating circuit, some example. As I said, if you need more information, you can go to Synco 700 from Siemens to study more about it. Great. Okay, so in next part, it's function and type of heating components. So what are the type of heating? The book discuss about it. The book said the type of heating is generally defined by the client or planner, means mechanical planner. Related to the type of heating, it is important to know that the low temperature set for all conventional heating, maximum flow temperature is 75, and minimum temperature is used for underfloor heating, and or for heat pump or solar panel, maximum flow temperature is 50. Okay, so this is the temperature of the hot water in these systems, low temperature or minimum temperature devices. Related to the generation of energy, type of primary energy is important. Are you going to use the gas or whatsoever? Related to the number of energy sources, is a single boiler system with or without hot water storage, or a multiple boiler systems. Okay. So let's go for heating elements. This is a heating time. It is important to know it because when we define, for example, the coefficient of the PID controller, we can take care of it, or the cyclic time of the heating in controller inside of the devices. First of all, we discuss about the radiator. It is a hot water convector heating. Okay, the application area is for residential and functional building. The reaction is quick. It means when you enter the room, you open the valve and it starts to make the room hot. The flow temperature is between 35 to 70 degree. Type of control is 0 to 10 if you use to control the valve, 0 to 10, or 3-step or on-off. About the underfloor heating, the next type of the indoor HVAC system. It is used for residential and functional buildings. The reaction is slow. It means it takes 1 day to make the room hot. Okay, so later we will see in controller the cyclic time is much more higher, like 50 minutes. The flow temperature is here is between 30 to 45. Additional it is going to control by continuous 0 to 10 volts or 3-step or on-off. The next one is hot water fan heating. It is more industrial. You can see, for example, in a large sport room they use it, or in warehouse. The reaction is quick, it is too noisy. The flow temperature should be the same, the boiler temperature, like 60 centigrade. The control is single or multi-level of the fan behind it, okay? The valve is open and it's controlled by the fan. The next one is electric convector, okay? So here it is used for the rooms that are rarely used. I mean, you use it for some time. The reaction is medium or slow because it's not so big, because it's used the electricity to make the heat directly. It's a basic heating and it's single or multi-level fan behind of it. The next one is electric fan heating. The application area is rooms that are rarely used. Reaction is very quick and about the single fan or some multi-level fan. And the last one is night storage heating. Okay, that's used in residential. The reaction is stores during the night, heat during the day. Comments is various type, and the type of control is based on the fan behind of it, single or multi-level. It is possible to combine these heating types. I mean, maybe you can see the fan coil, for example, with electric heating inside or whatsoever. The two-level heating, basic and additional heating, is an example of this. The basic level can be underfloor heating, slow, and the additional level can be hot water convector heating, quick. The reaction time during the warm-up storage is visibly shortened. So the book said maybe even in a room you can use two of them, underfloor heating and fan coil unit, for example. Then the book discuss about heating curve. Okay, why discuss about heating curve? Because we want to use the weather compensation. Okay, we want to change the set point of the boiler according to the outside temperature of the building. Look at this picture. If the outside of the building is not so cold, okay, so the temperature from output of the boiler that is supplied to the building is not so hot, it's a bit lower. For example, if the outside temperature in the building is about 35 degree, okay, this is external temperature. For example, if the outside is 10 centigrade, then the output of the boiler can be about 40 centigrade. But if we have the very cool day outside of the building, for example, some day that is 20 centigrade, minus 20 centigrade, then the output of the boiler is 60 degree, okay? So when we changed the output of the boiler automatically from 60 centigrade for some cool day to 35 or 40 centigrade for some warm day, then we can save energy. I mean, we reduce the switch of the boiler, okay? So we use less gas, less electricity, and so on. So it is called weather compensation. You should have this curve for your area and know the outside temperature, and then have this curve in your controller to use the weather compensation systems. So the next concept is about the placement of the heating system. The book said it should be placed in the coldest area in the room, that it would be below the window, and also the placement of the thermostat. Thermostat should be placed in the 150 centimeter from the finished floor, and at least we should be in 30 centimeter from the edge of the wall. Okay, the main concept for the thermostat is to read the very precise temperature. Okay, so we should put it in the right place. Also, it is written here, all the pipes of the wiring system should be carefully and sufficiently insulated. In well-insulated buildings, pipes without sufficient insulation can already heat up the rooms when the angle type valve is closed. Closed loop control is then no longer possible. When using room temperature control, no additional unregulated heating systems may be located in the room. Heating control. Various control systems are possible here. The necessary fail-safe circuit, example for the boiler, are not taken into account as they must be guaranteed by the device manufacturers. Let us look at the typical circuit for a hot water system with a single energy source compared with upper diagram. Control options according to the sensors. Okay, so here, for example, you want to control one boiler based on one room. Okay, only one room from several rooms. So the disadvantage is that the other rooms are dependent on the reference room. Okay, but if you have individual room temperature controllers, in each room we have the thermostat. So then each room is controlled individually, and it's so good. If you have a control dependent on the external temperature of the building, what's happening? Disadvantage is that you have no information about the building temperature. Okay, it means if the outside of the building is cool, so it gets warmer inside, and vice versa. External temperature and control value of the room temperature. Advisable if other rooms are used like the reference room. External temperature and control via the spread. Heat requirement is detected. Then, what is the difference between a direct heating system and mixed circuit? About the direct heating system, heat requirement can only be regulated by switching the secondary heating pump on and off. About the mixed circuit, heat requirements can only be regulated by opening, closing the mixing valve and via the boiler circuit when there is a lack of heat. So it's a different concept of the control. Okay? Notice that the commissioning of a heating system is generally carried out by the heating engineer, not automation engineer. Particular attention should be paid to the hydraulic adjustment of the system so that the control system can function without any problems. So notice that the hydraulic of the system should work well. I mean, in automation engineer, we cannot do the miracle for the project. If the mechanical part is wrong, we cannot do anything. Please remember that. Integration of the heating into the building management system, BMS. If the heating should be integrated into building management system, for example based on KNX, various solutions are available. Individual room control. In KNX we have many solutions for that. Heating system control, with and without influence from a boiler. The aim of this integration is increased comfort and effective use of energy. These words are so important because they are our goals in control of the HVAC systems in a building. So, the area of application of the control systems. If the cost of purchase is low, okay. The device example is like individual room thermostat, heating actuator, electrothermal drive, or electromotive drive. So the application is no intervention necessary in the heating system, only changing valve elements. For example, in a room you have the radiator, replace it with the automatic valve. The principle is opening and closing of the load circuit. If you need heat, the valve is open, and vice versa. The cost reduction by decreasing energy consumption. Okay, so here, depending on the room usage, if you are in room or not, little use, more saving, no influence from the boiler. Okay, so it is individual room control. Now it is possible for every building, and it is so popular. We have the many solutions in KNX. The next one is cost us the medium. So here, the device example is central control unit, or via the analog digital input output like PLC with proprietary sensor or sensor with KNX capability, mixed circuit controller like shutter actuator and mixing valve, pump control, switch actuator plus pump, 0 to 10 volt interface, increase or reduce the boiler temperature. Okay, so it is more complicated one. It is used for installation with the mixing valves in the heating circuit without direct access to the boiler via the KNX gateway. The principle is mixing and controlling of load circuits, increase and reduction of the flow temperature via the analog or digital input signals. About the cost, considerable saving for installation with a storage capacity, as only the required energy is taken from the tank and thus long operating times. And the third one, it cost us high. It's high with purchase. It's called heating system with boiler control. So the example is manufacturer specific gateway for the specific installation type. For installation with direct access to the boiler via the KNX. So here we directly control the boiler. It costs us a bit high. Boiler control and mixing of the load circuits. So we have the full control in the system. Large reduction as the complex installation is controlled at the optimum level. For example, we have the demand control in a building. No heat requirements, so the boiler is off. So this is a demand control. So in a word, if you need to save more energy, you should pay more. Okay, and if you aren't pay less, so the control system should be less complex, and lower saving of the energy. So let's go for the individual room control. It is based on two-step control or continuous control, like three-step control, and so on. The principle of the individual room control. Please look at this closed loop control. It is so important. In each thermostat or closed loop control, we put the set point. Okay, for example, in a winter, you ask the thermostat for 21 degree centigrade. Then in the thermostat on the wall, there is a room temperature sensor. It reads the room temperature. So from this comparator, there is an output. It's called control error. Okay, so for example, the room is 18 centigrade. You set the set point 21. Then the control error is 3 degree. This 3 degree is going to the PID controller. The PID controller calculates the control value. So the control value is the output of the PID controller, and it's going directly to the valve actuator or fan coil actuator. And it's going to the system devices like heater or fan coil or whatsoever, and change the amount of opening of the valve or the speed of the fan, and later it influence the room temperature, and it tries to change the 18 to 19, 20, 21, and then switch off the HVAC systems because already we reached the set point. So this is a closed loop controller that we have in each thermostat in the room in KNX devices. Then the type of control is, first of all, we have the simple one, two-step control. You can see in the picture, two-step control is open, close, on, off, and the output is oscillating around the set point. But if we have the continuous control, PI controller, you can see the purple output of the system. It has the movement very nice without any overshoot, and the settling time is low, and it's going to be near the set point in the room. So the PI controller is quite acceptable for our usage. You can see the feature of the thermostat. In each thermostat we have the knob or something to set the set point. We can define the special mode like comfort, standby mode like we call also pre-comfort, economy, night operation, and building protection. Also, it is possible to change the mode to the heat, to the cool. And then it is possible also if, for example, we have the fan, we have the manual fan speed controller. Okay? And then also in KNX it is possible always to connect the thermostat to the contact sensor to the windows to save energy, because many times people want to open the door, open the window, and at the same time the systems, the HVAC systems is working in the room and we lost energy. So we can put the system automatically to the economy mode. Anyway, this is a standard type of the thermostat. Then in control objects, in group objects, we can have the 1 byte information, useful information for the special mode to change between protection mode, comfort, night, and standby mode. Yes, it is possible. You can go for this to the DPT type. The book provides us some examples. Of course, in ETS you can see more. Okay, so we have two type of controllers that in parameter setting always we choose it, which type we need it, but I recommend you to go with PI controller. Okay, so as an actuator, the book provides us some example of heating actuator. So this is a heating actuator with only 1 or 2 output that you can connect it to the valve. For example, here it is written you can connect each channel up to 5 thermoelectric valve drive. Note that in the project, during among the KNX devices, if you want to control the valve, always try to use heating actuator instead of switching actuator, because in heating actuator, when we use it to control the valve with PWM control type, PI PWM output, so we switch on and off the valve many times, so the life is quite good to apply the controller output. Okay, if you use the switch actuator, the life of the actuator will be less. Okay, also it is possible to use the direct electromotor for the valve with KNX connection. Some companies like Schneider Electric, ABB, Teben, and so on provide such these products. So the PI controller are inside of this actuator. So here the advantage and disadvantage of continuous and thermoelectric valve drives. About the valve drive, continuous means we can control it between 0 to 100%. The advantage is connection only via the bus. Here you can see it. The status display or control value can be read in details. You can know it. Very precise control. It has very precise control. Okay, so because it can control the opening of the valve for the radiator or underfloor heating between 0 to 100%, percent by percent. The disadvantage is only one valve can be controlled. Of course, you can control only one valve. Yes, you cannot connect several valves to one actuators anymore. And the higher current loading on the bus. Yes, it needs much more current. So you know, in a KNX power supply, we use the 160 to 1280 milliamp. So it affected. And the high cost. It is so expensive. For each valve, it costs about €200. Thermoelectric. So if you use the on-off valve, what's happening? The advantage is a status display. Of course, there is some display on it. Low cost, no high bus load. It is very cheap, like €50 with everything. You can use several valves per actuators. Of course, you can have a fan, heating actuator with several valve drives. Noise free. It is noiseless almost. Disadvantage is additional power supply required. Of course, you should provide 24 volt DC or 230 volt AC for that valve drives with the KNX actuator, the heating actuator. And the higher installation costs. Yes, it needs more costs, more wiring diagrams. Yes, great. Further elements. The basic elements of an individual room controller are the room thermostat and the actuators as described above. To be able to improve the effectiveness of the circuit, further elements can be integrated. Time switch. So time control of the operating mode. We applied in KNX for a small project. When we use the mini server, we can apply time. Or maybe some thermostat provide you the time functionality. Or use clock in your system. And for the big project, you use the server. So the next one is window contact with the binary input or push button interface. So control of the frost protection mode. It is also helpful in the individual room controller by KNX. If somebody opened the room during the winter, the protection is activated in less than 7 degree to not make ice in the systems, the piping, or even in the rooms that the split unit is working during the summer. For example, we can save energy. If somebody opened the room, open the window, then the systems go to standby mode. The next element is display of a temperature value and selection of a new set point temperature. We use it. PIR motion detector, control of comfort mode. For many projects like offices, if somebody is in the room, so the HVAC system is working, and if there is nobody in the room, the HVAC system is switched off. So this is because of the motion detector or presence detector. Logic. So we use logic to operate the HVAC system. For example, in hotel rooms, always we use logic. Great. So this is the end of part 1 of our presentation. See you in the next part for the HVAC part.